Okay, two cyclists A and B are riding on a field. The cyclists are modelled as particles and the field is modelled as a horizontal xy plane with the point O as origin and unit vectors parallel to axes and y axes denoted by I and j, etc, etc. Time t equals 0, A is at the point 0, at origin, sorry, and B is at the point with position vector 69 minus 32j. Cyclist A moves with constant velocity 49 minus 17j, and cyclist B moves with constant velocity 13i minus 15j. Okay, write down the position vectors. Okay, so to get the position vectors, we have to go with the velocity to start with, okay? So in this case, velocity of cyclist A is 14i minus 17j, alright? And then, that's the direction it's heading in. So then to get then position vector, we can integrate. Okay, so that's the velocity's derivative of the position vector, displacement. Okay, so when we integrate this, separate the variables. So you get RA is equal to 14ti minus 17tj, plus of course a constant. And then we could say, of course, when t equals 0, if you notice it said up there, A is at the point O. In other words, RA is equal to 0, which implies then C is equal to 0. So therefore, RA will quite simply equals to 14ti minus 17tj. Okay, do the same then for RB. Okay, so you'd end up with a similar sort of integral when you'd have the velocity was 13i minus 15j. Okay, so RB would equal 13ti minus 15tj plus the constant, we call it d this time, and then when t was equal to 0, RB would equal, now did it say up here 16i minus 32j, yeah? Okay, so that wasn't at the origin. So that means then, you know, chuck it in, you'd have 16i minus 32j equals to d, because the times would be 0, that would go. So therefore RB would equal 13t plus 16i, and then minus 15t minus 32j plus then constant d. Okay? No, I've already worked out d, sorry, I've done that, haven't I? Excellent. So, it says then, write down the position vectors of each cyclist at time t. Well, I've done that. Calculate the distance between the cyclists when t equals 2. Okay, so all I've got to do when t equals 2, work out RA. So RA would equal 14 times 2i minus 17 times 2j. So that would be 28i minus 34j. And RB would equal, if I chuck it in there, 13 times 2 plus 16i plus minus 15 times 2 minus 32j. Okay, so I'll work that out there, 42i minus 62j. Okay, so then to get the distance between them, okay, I'll do it up here. To get the distance between them at t equals 2, you just need to, again, think in terms of vectors, right? Because that's what we've got, A and B. Okay, so to get the distance between them, you'd want AB, wouldn't you? Okay, you'd want that there, AB, and to get AB, you need to go along AO and then OB. So AB is AO plus OB. Okay, and AO, remember now to get AB, you need to go AO, so that'd be the opposite of RA, so that'd be minus RA plus then OB. So RA minus, RB, sorry, minus RA. Okay, so if you take these two answers down here, RB, that take away that basically, RB take away that. And if you do that, you get 14i, and then that take away that, you get plus minus 28j. Okay, that's RB minus RA from here. Now to get the distance, of course, you need to look at the actual size of this. So we're looking at Pythagoras 14 squared plus 28 squared, basically. And that will come out to be 31.5 0.3 meters per second. Okay. And then it says determine whether, okay, so part C then, it says determine whether the cyclists will collide. Now of course, if the cyclists collide, then we set these to equal to each other, don't we? RA will equal RB, right? If cyclists collide. In other words, that 14t will equal this here. Okay, so we put the i's together. So 14t equal 13t plus 16, which implies t would equal 16. Okay, and put the j's together. So minus 17t. So the i's I'm equating, and then we're going to equate the j's. So minus 70t equals minus 15t minus 32. So that would be, what's going on here? So 2t or minus 2t would equal minus 32. So we also get t is equal to 16. So as the times are consistent, okay, for I and j, then particles will collide. So particles will collide because times are consistent for I, j, so they're going to collide. Excellent.